Hello? 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 Oh, Avery! Come on in. Oh, you're here just in time. We're about ready to start lesson number one. Lesson number one is about, it's kind of transportation systems. It's about the history of starting from walking to carrying to carts to wheels and axles, and finally getting to train systems. I know you're very interested in that, so we'll make sure we get there. And then we're going to talk about steam power, because you were interested in the steam locomotive. We're going to talk about steam and how it's made and where it comes from and how we do it. And then the power part of it. How do we put it together to make something go out of it? We're going to establish some equations. I'll show you what those are. Sometimes you have to use math for that to show how things function together. But we'll talk about that. And then we're going to eventually get to the steam plant itself. So it should be pretty exciting. So we'll see what's taking place here now. 1 second. This is our guide for today. It's called Transportation Systems. It goes through, as I said, history, and then we're going to talk about states of matter, which I know you already know about, but then we'll review it. And we'll talk about pressure. How do we get pressure? Where does that come from? And then that leads us to the steam plant, which should be very, very interesting. Let's discuss and look at a couple of little demos that I want to share with you first. First of all, we started with running or walking or whatever. It was difficult for people to do. They couldn't do very much other than that, and then they had to go out and look for food and things to bring home. They would have to bring all that back, and it was heavy, and it got worse and worse and worse. And eventually, they started putting little packs on their backs and carrying those particular things and lugging everything back home. There she goes. That's my trusty assistant. She's got a whole bunch of stuff she's trying to carry home. And then individuals started riding horses and donkeys and mules and other animals. In fact, let's see how many you can figure out yourself how many they did. Farmers needed to take a lot of their stuff to market sometimes, and it became heavier and heavier and too heavy for them to take it, and the distance became even longer. So they had to come up with other solutions. One day they decided that they could put it on a bunch of logs and roll it and pull and pull and pull and pull and help to bring the biggest things that they possibly could. At about the same time, several thousand years ago, there was an adaptation from a potter's wheel to a wheel and axle combination, which was a tremendous move. The wheel, like the logs, plus an axle, and that became a tool they could pull things with. Let's see how that has helped us. Put animals in it to pull. We've got a moose.
In here?
No, the moose is going to be pulling instead of you.
Oh, gee. Oh, so we just let it look
You
that
could
way.
just let it look like that if you want.
We do have some horses upstairs.
I couldn't find it. I looked.
They're in the bucket
Moose is better.
next to the barn.
You ready?
No, I gotta get out of the way.
Okay. And then, eventually, they were able to put animals in front of the cart and pull it. But something was missing. Something was missing. How can they make a train like this? And that what was missing was an engine. I'm going to take a break from that right now, just for a minute or two, and we'll play that aside. We've got the cart, it's got animals, but we don't have an engine. Where do we get an engine? And to start that discussion, I want to talk about states of matter. What is matter? Well, matter is everything that's around us. It's where you're sitting, it's your book, it's you, it's a tree, it's a rock, it's the oceans. Everything is matter. It's all made up of individual atoms. Some of these different atoms, like Gold has some atoms in it, makes it an element. Silver does. Sodium does. Chlorine does. Now, if you take sodium and chlorine together, they bond very, very tightly and create salt. Now, if you take two hydrogen molecules and one oxygen molecule and put them together, they bond very, very strongly and produce water. Now, some things don't bond very well. If you take the salt and you put it in water, they don't bond together. You get salt water. And you can separate those things. These other particular compounds that are bound together are very, very hard to separate. Now, there are states of matter. Matter comes, as you know, in different forms. First of all, there is the solid form. Rock hard, like a rock, like a piece of ice, like a tree. Those are solid, they're rigid, they stay in their same form that they are. Then you have the second state is liquid. And that is like water, like molasses is probably a liquid, like orange juice. All those things that flow and can change their particular shape. Not rigid like a solid, but can change it as time goes by. If you spill a glass, the water in the glass changes shape and it's all over the table or your clothes. Or like me, all over my desk. The last is gas. As we apply energy to the liquids, the atoms start to spread apart. And they get further and further apart as they absorb this particular energy, and they either increase their volume, or if they're held in some way, they'll increase the pressure inside. And those are the three states. It's a solid, it's a liquid, and it's a gas. Let me show you a picture of something, just to clarify this for you, because I know you know this. This is a picture of, on the left-hand side, as you're looking at it, is the solid ice. Oh, we see that all the time up here where we live, right? Next to that is, as it heats up a little bit and warms after a period of time, it changes to water. And then, as it's heated up even more, perhaps from the sun or from some other external source, it turns to a gas, which you can see is vapor, which is like the clouds. There is another form, and we don't talk about it, but it's called plasma. It's when things get extremely hot. It's called plasma. And that's a good example of that is the sun. But we'll talk about that later on when we get down into some science. Now, we can change those states, as I'm sure you know. We can boil ice and change it to water and keep on going, and it becomes into steam. And steam, as you know, if you have a cover on top of your pot, it's going to start bubbling and bouncing up and down and things like that. It's because the pressure is changing and the volume inside is changing. This is an equation. Now, an equation, and I have it, the equation is the top part. The PV equals to T. The equation is a relationship. The pressure and the volume are on one side of this seesaw. The temperature is on the other side of the seesaw. Now, as a science and a mathematicians, we found some pieces of math that make these things exactly equal. Right now, I just want to show you the relationships between those two. If we increase the temperature and make it heavier and it gets higher, that seesaw is going to come down on one side. If we want to make it exactly equal again, like a seesaw, we're going to have to increase either the pressure or the volume. So if we increase that temperature, and we have it maybe in a pot or in a jar or something like that where it can't increase its volume, then the pressure has to increase. So what happens is we heat the water and the steam comes out and the temperature goes up. Something on the left side of this equation has to increase. Maybe the steam will go into a balloon, and that'll increase the volume. Or the steam will be restricted from moving, and the pressure goes up. And that's the relationship between these two things that we're going to talk about as we go forward with the development of a steam engine. This is one of the first experiments that were done thousands of years ago, I think. It was creating a small little steam engine. You'll see on the bottom that there is a fire heating a bath full of water. The water cannot go anywhere, so the volume's not going to change. So it changes to steam. And then the steam from here goes on up these particular tubes and into this little circular vehicle right here, and comes out these two spouts that I've marked with the red arrows. And they actually produce propulsion. It's a little kind of crude steam engine, but it was the first demonstration of how you can take steam and convert it to some kind of a machinery.